This is IC 120 looking upstream. It looks like there are two little low flow channels in the stream bed.
Then it seems like they're almost coming together there.
Yeah. Yeah, they come together in that area. Quite a few trees down in here, right in the middle of the stream bed.
And this is the other side where the outfall kind of Indian Creek, once it has crossed Airport Road. So it looks like this is about a 5-foot tall little tunnel that leads to a creek underneath the road.
This is still IC 120. For reference, my car's over there. So in the last video, we just walked along that stretch, and then here I've crossed the road to look at this other side. There is a lot of vegetation in Indian Creek right here. Some trees. These are right in the bottom, growing out from the bottom of the creek bed. And one thing of note at this site, I don't know how well you can see it, but maybe you can hear it. Back in this area, there's a large construction project going on. This is IC 220. Here we're on the south side of Rio Grande Avenue. And you can see we've got a nice little flow here. There's quite a bit of grass. And it looks like there's even some algae on the rocks down here. And the water looks really clear. It's a nice, steady, small flow. And then it's entering these two pipes. The big one that we could see from the other side, and then the small one as well. It looks like it's flowing mostly into the big one rather than into the small one. Unfortunately, we can't take our sample on this side because we have some access issues. There's a barbed wire fence that cuts all the way down through across the stream and then continues up that way. So we'll be taking the sample on the other side where we can actually access the water.
So this is the PC320 site. There's definitely some suspended solids. There's some erosional stabilization happening, and definitely some algae as well on Plum Creek.
Okay, so this is side PC320 where Plum Creek crosses Airport Road. And we have 3 different sampling bottles, one for TSS, a 1 liter bottle, and 300 ml bottle for FIV, E. coli, and coliform. And then a 250 ml beaker to just take a sample for the alkalinity measurement, pH, and conductivity. So the first sample I'm going to take is for FIV. What's important here is that we want to rinse and completely submerge the bottle in the water itself. By doing this, we're making sure that any contamination that may have happened, like any microbial contamination that may have happened with the sampling bottle, is just going to be kind of over, or like rinsed off by the actual microbial community living in this room. And I want to make sure that I do the same with the lid. Just make sure you're not losing it. Once I've done that, I will actually take the sample.
This is PC 420. Here I'm standing under the bridge that goes over Plum Creek. Looks like we have a bit of a retaining wall here. We're gonna take the sample a little farther upstream, but the water here is pretty clear. And I think we're gonna try to take the sample from right over there. You can see Andrea walking out now.
So here I will show you how to distribute the sample that we've just taken into the different sample vials for further analysis in the lab. The one I'm going to start with is total metals. So this is for the site PC 320. And total metals is always unfiltered. So we're just going to simply fill up that 15 ml Falcon tube. And then the dissolved metals, also 15 ml in a Falcon tube, will have to be filtered, and also the sample for IC, COD, and DOC. So what I'm going to do is, first we need to kind of rinse the syringe and the filter. It's a 0.45 micrometer filter. So I will fill the syringe up, a little bit more than halfway, and then rinse the filter into my waste bin. Once I've done that, I'll take another sample. I can start filling the different vials. So I'm going to start with dissolved metals. And the next one is the 60 ml for the anions and dissolved organic carbon and chemical oxygen demand. As you process or filter more of the sample, the filter may get clogged, so it may need more or require more force to push the sample through the filter. So these 3 samples are now going to be stored in a bag for analysis in the lab that I labeled the sample ID, the date, and my initials, the FIB sample bottle, and sample bottle for TSS. They have already been put into the sample. I'm also taking an unfiltered sample here in a 50 ml Falcon tube for subsequent pH and conductivity analysis. I'll show later. What we're going to do here as last thing is the alkalinity. So you need this little digital titrator. And you kind of need to make a good guess for like how much sample volume you're going to take and what the strength of your cartridge is. What I'm going to do is I go with the lower strength cartridge, so 0.16 normal of H2SO4, and I'll go with a sample volume of 25 and then fill it up with DI water. And that's just simply because we've analyzed other samples from Plum Creek today already, so we kind of know that that's a good estimate. So I take 25 mils here, pour that into a 100 ml beaker, and then I'll take 75 mils of DI water. Perfect. So that's the Bromkrasl green powder pillow. Shake it a little bit, and at the same time, I'm setting up the titrator. So you'll take off the lid, add the little hook here. So once you have prepared the titrator, added the little hook here, and you want to make sure that all the digits are set back to 0, so you are good for a fresh start. You want to swirl a little bit and then just start titrating that acid into the sample and kind of give it a slight swirl from time to time. So you see that wherever the acid drops into the sample, it's turning a little bit pink, but then you know, this is reversed, so we need to add more acid so that the full sample volume is going to turn pink and stay pink. So we're almost there. It's kind of almost at a neutral color right now, and I think, again, almost there.
There it is. Yep. It's slight.
I think we give a little more, so that's a real pink. That's what we want. Yeah. So the titrator is saying 229 digits. We have 25 mils of the sample volume, and we're going to have a digit multiplier of 0.4. So we're going to adjust that 229 by multiply it with 0.4 to get the end concentration of calcium carbonate in the sample. So we're going to analyze a sample from PC 320 that's not been filtered for pH and conductivity. So the first thing you want to do, you take out the multimeter, then you connect the probe. In this case, we're going to start with the pH probe. And the important thing about the pH probe is that it has to be stored in a storage solution, so it should never dry out. So what you're doing is like you're unscrewing this little bottle, then you're taking the cap off, and you want to put that somewhere where it doesn't fall. And then always rinse the probe in between, between storage and a new sample or calibration with the water. And then blotting it dry with a Kim wipe. I'm going to turn on the multimeter. And the first thing we have to do is calibrate the probe. What we typically do is a 3-point calibration, starting with pH 4, then pH 7, and at the end pH 10. So you would go to your multimeter here and press calibrate, and it's going to tell you to rinse probe, which we just did, put it in a buffer and push the read key. That's what I'm going to do. And I like to put the tube with the calibration solution in something steady so it doesn't fall. And I always kind of give it a slight swirl while it's in there, and then I press read. And just wait until it's stabilized. So we're already there. You're going to rinse the probe again onto the pH 7 calibrant solution. Press read again. You hear the beep, it's stable. It's at exactly pH 7 actually. That's great. The last one is pH 10. It's stable at 10.02. So that went pretty fast. Now you can push the done button here and also push store. And so it's going to store that calibration, and you get to measure the pH of the sample you're interested in. And press read. So it's stabilized at 8.23. And we're going to do triplicate measurements. So I'm going to push read again. 8.22, and the last reading is 8.22 again. So at the end you want to rinse the probe again, let it dry, and you can turn off the multimeter. The last measurement I'm going to show you guys today is the conductivity measurement. So again, we're looking at a sample from PC320. It's not filtered. So you would just connect the conductivity probe onto the multimeter, turn it on, and so first we're going to calibrate it using the 1413 microsiemens per centimeter calibrant solution. So just as a warning, this morning the conductivity probe did not work. Oh sorry, first we would rinse it like always. Make sure that I'm following the protocols here. So the probe didn't work this morning, so we're gonna try it again. It did calibrate, but in the end it didn't give us any reading when we measured the sample. So let's see what it does now. So we'd go to calibrate and then press read. And this might take a while to stabilize. So the value it's stabilized at is 1378 microsiemens per centimeters. So that's close enough. So now let's see if it can give us a reading for the sample. So it's doing that again. I'm not sure if you're able to see it. It's just not stabilizing the bar. It just stays close to zero and it's showing no value. So we have no idea what's going on with the probe. That's when you know something is wrong because you should be seeing a value.
This is actually the last site that we are going to for Group 5. We're currently at site PC320. And so I just wanted to show you how we've been filling in this chain of custody. Our client here is the Chatfield Watershed Authority. So they're listed up here at the top. Since we're in the field, I'm not including all of their information. I can look that up back in the office. But the sampler's name is really important to include here. So Andrea Portman is the primary sampler for Group 5. And then I have my name as the second sampler because we've been working as a team this morning. And then the project name I've just included as CSM Field Session 2020. The rest of this is some invoice information. We aren't invoicing anyone for this, so I haven't filled that in. But really the meat of this document is down here, where we identify every single sample that we're collecting in the field. So I'll be showing you, I'll unclip it so hopefully you can see it a little better. We'll be filling in the rest of these last 4 rows. So we have sample taken from PC320 for FIB, fecal indicator bacteria, and then TSS, IC, DOC, and COD. Those are all in the same bottle. Dissolved metals, which I've abbreviated as DM, and then we are going on to a second sheet with our total metals, TM. So let's go ahead and fill this in. Our next column is the sample matrix. So we want to let the lab know what kind of sample we're bringing their way. So down at the bottom there's some information on what sample type you could possibly have. They list drinking water, groundwater, wastewater. I don't really know what wipe is. If anyone knows, please inform me. Solid or soil, sludge, air, oil, organic liquid, and other. So really ours kind of falls under other because we don't have drinking water, groundwater, or wastewater here. But I went ahead and just added another one, SW, for surface water. It seemed a little strange to me that that wasn't included here. So all of these are surface water samples. They were taken at the exact same location. So I'm just writing in surface water and then quotes down the rest of the row if it's all the same as that row. The regulatory program for this is going to be N. Again, that's listed down here. N is NPDES. That's the National Pollutant Discharge Elimination System, which regulates surface water. And so that would be the regulatory program for all of these samples. Up here, we've taken all of these samples on the same day, so I'm just going to include quotes. Samples were taken on May 7th, 2020. The sample time, this sample was collected at 12:15 p.m. Alright, and it is a grab sample, so this is asking if it's a composite sample, so it's where you take a little bit of sample over a period of time and create a composite, but we just went up to the stream and all at once dipped our containers in and took a grab sample. So we're just going to list G in that first column for all of those, and then the number of containers. We only have one container for each of these sample types. And then we aren't doing any field acidification or preservation of these samples. All right, so our FIB sample is collected in a 300 milliliter plastic bottle. That's listed, hopefully you can see it okay, up here at the top. And then TSS was collected in a 1 liter plastic bottle. IC, DOC, and COD was collected in a 60 milliliter amber glass bottle, and then dissolved in total metals were both collected in 15 milliliter ICP AES vials. All right, and total metals wasn't filtered. However, we did filter, because in this last column it's asking, well, second to last, before the comments, it's asking if we filtered the samples. We filtered in the field for dissolved metals, and we also filtered in the field for IC, DOC, and COD. And everything else is unfiltered, and will go back to the lab in a cooler.